In this lesson, we are going to talk about the application of sine and cosine functions. In this example, we have the population of Canada for people aged from 20 to 24 years old by the year. For instance, 1976, we have 2.253367 thousand people, 2,253,367,000, and so forth until 2005. Just by looking at the pure data, you cannot really see any type of relationship. But if we translate this table to a graph like this one, then obviously you can see the pattern which shows a periodic function. And since it's a periodic, we are able to somehow try to fit a sine or cosine function to this data. The first example that we are going to consider is the relationship between the height above the ground of a person riding a Ferris wheel and the time that it takes to reach a height using a sinusoidal function. The first part of the question asks, what will happen if the platform from which the person enters the ride is raised by 1 meter? To answer this question, first consider not raising the platform. How does the graph looks like? The height versus time. When the person it goes here in the Ferris wheel, the Ferris wheel turns counterclockwise. It reaches a maximum here. Then as time passes, the height decreases. So our graph, without raising the platform, looks like the following. If t represents the time and h represents the height, at time t equal to 0, we know the height is 0. Then as time increases, the height increases until it reaches a maximum which corresponds to this point. Then the height decreases until it reaches 0, which is this point. And again the height increases and then decreases, increases to decreases. This is how the graph looks like. You may be wondering, it doesn't look like a sine or cosine function. How come we call it a sinusoidal function? The reason is that, first of all, this is a periodic function, because every period the graph of the function is repeating. So this is a periodic function. That's the first thing. Now let's see what will happen if we raise the platform. If the platform now is here, you can see that when the person enters the platform, the height is not 0 anymore. So the height is going to be somewhere around here. Then as time passes, because the Ferris wheel turns like this one, then the height decreases and it gets to 0. But this function, this graph that we have here, it starts from 0. So the only thing we can do is that, remember before I continue, is that this graph repeats itself to the left the same way too. So the graph really looks like this one, going to the right and the left. Now, if we want the height to be something other than 0 at time 0, then it means that the graph is going to be shifted right. So this point is going to be the beginning. So we are going to have a graph like this one. This is when he enters the Ferris wheel. Then for a little bit time, the height decreases until it reaches 0. Then it's going to maximum, then minimum, maximum, and minimum. So this means that if the platform is raised, then it means that we have shifted the graph to the right by some time. This is why we say we have introduced a phase shift here. The graph has moved to the right. The next part of the problem says, what will happen if the Ferris wheel turns twice as fast? Again, consider the normal speed of Ferris wheel. We're going to have a graph like this one. Now, if the Ferris wheel turns twice as fast, then it means it reaches the maximum twice as fast as before. So it means that now in one period, which is here, we are going to have twice the graph, meaning that we are going to have two of these. Here we are going to have two of these. This means that the graph has been compressed horizontally by a factor of 1/2 now. So if we increase the speed of the Ferris wheel, we are going to introduce a compression of the graph horizontally by a factor of 1 over the increase in the speed. For instance, right now it's twice, so it's going to be 1/2. The next example, we have the height h in meters above the ground of a rider on a Ferris wheel after t seconds can be modeled by the sine function h of t is 10 sine 3 times t minus 30 plus 12. We are supposed to graph the function. To do that one, we need our a, b, h, and k. We know that a is equal to 10, b is equal to 3, h is equal to 30, and k is equal to 12. This means that our mapping notation is xy goes to x over b, which is x over 3, plus h, which is 30, comma, ay, which is going to be 10y plus k, which is 12. Now our table of value for base function y equal to sine t for t values. Remember, the x here is really t and y is really h. For the special angles 0, 90, 180, 270, and 360 are 0, 1, 0, -1, and 0. Applying the mapping notation to this one, we divide x by 3 at 30. So 0 divided by 3 is 0 plus 30 is 30. 90 divided by 3 is 30 plus 30 is 60. 180 divided by 3 is 60 plus 30 is 90. You can see that the increment is 30, so the next one is 120, and then the last one is 150. For y values, we are going to multiply by 10 at 12. So 10 times 0 is 0 plus 12 is 12. 1 times 10 is 10 plus 12 is 22. Again 12. And then -1 times 10 is -10 plus 12 is 2. And 0 times 10 is 0 plus 12 is 12. Now we have to plot this function. So this is going to be our t, which is the same as x. And this is our y, which is the same as h. Now, if we look at the x values or the t values are 30, 60, 90, 120, and 150. And our y values, the minimum is 2, the maximum is 22. So if this is 22, then this is 11, then we can assume that here is 2. So this is our maximum, this is our minimum, and 12, which is somewhere around here, is our midline. Now we know that the sine function has the pattern which is intercept, maximum, intercept, minimum, intercept. So we are going to start with 30, which is going to be our 0, or intercepts, which is here. 60 is going to be our maximum, which is 22. Then it's going to be again at 90, which is going to be our 0, x-intercept. Then it's going to go to minimum at 120, which is 2, which is somewhere around here. And at 150, it's going to go to 0 again, which is 12. So our function is going to look like this graph. The next question is, find the maximum and minimum heights of the rider above the ground. We know that the maximum value of sine of any angle is 1. So the maximum is 10 times 1 plus 12, which is 22. The minimum value of the sine function is negative 1. So we get negative 10 plus 22 plus 12 is going to be 2. So the maximum height is 22 meters and the minimum height is 2 meters. The next part of the question says, find the height of the rider above the ground after 30 seconds. So we are going to substitute t equal to 30 in the equation, so it becomes y is equal to 10 sine 3 times 30 minus 30 plus 12. 30 minus 30 is 0. 0 times 3 is 0. Sine 0 is 0. 10 times 0 is 0, so the answer is 12 meters. The last part of the question says, find the time required for the Ferris wheel to complete 1 revolution. So for this question, to answer this question, we're going to go back to the graph and we're going to look at the period by investigating the graph. By looking at the graph, we can see that the maximum, that one intercept occurs here, the other one occurs here. This represents the beginning and end of one cycle, or it's the length of a period. So the period is 150 minus 30, which is going to be 120 seconds.